Welcome everybody. Hopefully you can hear me, hopefully you can see me and all the normal stuff that we hope to have on a Zoom session. Welcome again to Office Hours. I'm not sure what Office Hours is for me. It's almost getting up to number 30 in terms of this one. You may have seen, not that you probably care that much, that I've renamed this from Database Administration Office Hours to General Database Office Hours. Really just to reflect the fact that the questions that are coming in from people are so broad. Sometimes they're admin focused, sometimes they're development focused, etc. What I've tried to do is generally steer away from purely SQL-based questions, because obviously my partner, Chris Saxon, has a SQL-based office hours as well. So hopefully between the two of us, we cover everything. So welcome along. Hopefully you've been perhaps attending some of the other Oracle stuff that's been going on today if you're more of a developer focus, but we'll talk about that in a second. Let's now share my screen and get into it. Okie dokie, as I said, for the last few months, I'd imagine you've probably been on a few Zoom calls of late, especially if you're not working back in the office yet. Just about everything's done through Zoom. And because of that, even though I very much appreciate you coming along to Office Hours, I love the fact that we get to have a chat and talk about some cool content. They're all recorded. And what I do is, if you can't bear the thought of listening to me for a solid hour, what I do is we publish the entire recording on the Office Hours page on Ask Tom, but also I'll go through each of the questions and chop them up into individual videos and put them on my own YouTube channel, which you can see there. It's just Connor McDonald Oracle. And in that way, you don't have to subject yourself to an hour. You can just basically flick through the bits and pieces that best suit you. Normally, I get those videos out in the next sort of week or a couple of weeks after the event. The main full hour one will obviously be out hopefully sometime tomorrow for your viewing pleasure. Other than that, if you want to get in touch with me, love talking technology. Hopefully you had a little bit of fun if you watched the DB-talk link I put there while you were waiting. Just a bit of fun about what I think database professionals often talk about. But if you want to get in touch with me, linktree/Connor, that'll have my Twitter, my blog, email, Facebook, Instagram, LinkedIn, however you'd like to get in touch with me. Happy to talk tech. I do my best to talk to anyone that reaches out to me. Please follow me on Twitter. For those that are new to this session, the slide content is generally pushed down toward the left. That's why I say do not adjust your set. It's such that we can make a better YouTube video at the end of it. As I always do on Office Hours, I like to cover off a few little bits and pieces about what's coming up for me and hopefully to inspire you to be involved in your local community user groups. As of today, in fact, throughout today, you would have hopefully been attending some of the developer focus sessions on our Developer Oracle.com continuation of the developer series. Last month it was database. This month it's like Java, MySQL, more of a sort of front-end developer kind of focus. Lots of talks, and just like Office Hours, they'll be recorded if you missed them today and will be available for replay. Things I'm involved in, the APAC Oracle user community is basically doing a tour, a virtual tour. So unlike the days where we would say, look, come to a talk in Australia, and everyone's going, I am not sitting on a plane for 25 hours. You can do it now. Hopefully you can just come along and do a virtual presentation. We'd love anyone to come along and assist with virtual presentations, because it gets you a look at a new community and obviously hopefully entices you to come back when things do reopen. The Groundbreaker virtual tour in Europe is coming up. I'll be doing a talk at that, so check out that website below. I think the agendas might even be out. That'll be throughout Europe as well. I'm doing a talk for the Swiss Oracle user group. They do some fantastic events, and I'm very happy to finally be able to do one there. Hopefully I'll do one in person. The Spanish Oracle user group, I'm doing a talk for them. That's an interesting one. If you go to that website, you'll see they're doing rather than just being a Zoom session, as I said, a lot of us are getting a bit bored with just pure Zoom. They're doing what's called a virtual world, where effectively, I have no idea how this is going to work, but effectively you become part of a virtual world and people will give a talk in the virtual world. Stay tuned for that one. Speaking of virtual worlds, my standard public service announcement at the start of office hours, and that is, this is the graph updated as of today. I'm very thankful that we still get a chance to talk about technology, but I'm aware, for example, in Oracle Australia, we have had a few people, Oracle employees, been struck down with COVID. Thankfully, they've all made a full recovery. But I also know that there have been some family members of Oracle employees in Australia who have actually passed away from COVID. And in a global scale of thing, COVID cases in Australia is actually pretty low. So please look after yourselves. As I said, we only have a community if we actually have a community. We've got to have people involved. What are we going to talk about tonight? We'll hopefully cover off 5 things. We've got unused columns, DBMS job and upgrading to 19C, estimating the gains from doing database maintenance, how to manage large-scale data operations without interruption of service to the users, and if we get time, we'll just talk very, very briefly about standard edition licensing, because it was a question that came up to me directly, and I said, come to my office hours session and I'll talk about it there. So ultimately, that last one was effectively just getting my viewership up by 1, but hopefully we'll cover them all off. Some of these are pretty big topics, so we'll do our best to get through them all today. Let's get straight into unused columns. And we've all been there, that concept of my table has a certain number of columns, and over time, one of the columns or one or more of the columns is no longer required. And those of us who are from my generation would just simply leave those columns, because the only way of getting rid of them was to do something very, very significant and have a big outage. But we fixed all that stuff in about Oracle 8, I think. But here's the question that came in. I want to drop a column, and I did the drop column command. And when it was done, there were still entries in the unused tab, Cole's view, the view that shows you what tables you have set to, or columns you have set to unused. Now, that's a bit weird, because in theory, the moment you do a drop column command after a set unused, everything's cleaned up. We wipe the table of that data and the data is gone. So let's explore this, and we're going to go through a few demos now. But if you have to leave the call early, here's my too long didn't read lesson for this entire section we're about to talk about now, which is don't drop columns. Don't run the drop column command. Generally, I think it's just going to be a waste of time, and it's going to get you into more grief than you can possibly imagine. And we're going to explore some of that tonight. But yeah, if you want a simple rule of thumb, just assume the drop column command didn't exist, and I think you'll pretty much be good to go. So let's talk about theoretically, or visually, why I think drop column is a bit of a waste of time. And then we'll actually go through some real life demos as well. As you know, most of us, we have an 8K block size. Some may have 4 and 32K or 16K, but the vast majority of us have an 8K block size because it's the default. And as you create rows in a table, it's fairly simple what goes on. We allocate some space for a row, and then we fill that row with columns. So assuming a very, very simple example here, I've got the employee number, employee name, salary, hire date, etc. And yeah, just to make the visuals nicely, each row nicely fits and squeezes into that nice rectangular block nicely. Normally, of course, we don't do it that way. We simply append rows back and forth just continuously. As one row finishes, the next one starts. But I would then add more rows and more rows and more rows. And as we keep adding rows, eventually those blocks fill up and we move on to the next block, etc. And that's basically how Oracle works. It's not particularly rocket science. Now, when you do alter table set unused, let's assume this is probably a realistic demo in the current climate. Let's assume we're going to do away with salary. So when we do set unused salary, nothing actually happens to the data. All we do is we actually make an entry in the dictionary saying this column is now ignorable. We do nothing to the data. And immediately the salary column is gone. It's unusable in any way, shape, or form. But for some reason, people think that's not good enough. I always think that set unused is the intent of removing a column. You can't access it anymore. You can't get it back. It's gone forever. What's the deal? But people get upset because they say, well, there's all these salaries still floating around in my database. I would like to clean them up. but I want the space back. That's what people say. And so they go alter table, drop unused columns. But even with this very simple visual, it doesn't take a lot of effort to see what's going to happen. I'm going to walk through every single block, and inside every single block, look at every single row and wipe out that piece of data that's no longer required. And there go all my salaries. Now, there is indeed a chunk of free space now for every single row that we've touched in that block. But when I come along with a new row, where do you think that's going to fit? Because rows basically have to go in a contiguous space unless later on they get migrated or chained, etc. But out of the box, your typical row goes in a contiguous block. It doesn't matter that you've freed up all this space for each one of those salaries that you've reclaimed. None of them have offered you some space to put raw rows back in. So it's not going to go into that space you've freed up. It's actually just going to go into the rest of the table like a normal row. It's very unlikely that that space that you've got back using drop columns, unless the column is massive and a big chunk of each row, it's very unlikely that that space is going to be used for anything else. It's just going to be dead space. At which point, how would you have to get it back? You would have to actually reorg the table. Now, if you're reorging the table anyway, why would you go to the effort of running the drop columns command? That's a massively resource intensive exercise to walk through every single block in the table and do some work on it. Well, if I'm going to walk through every single block on the table anyway, why not just reorg the table? Because I'll get the space back then, as well as getting rid of that column. So let's look at a demo and see this in real life. Okay, now what did I call it? Unused. So I'm going to create a table. It's just a copy of DBA procedures. There's nothing special about DBA procedures. It's just a table with not too many columns, so it keeps my screen formatting nice, and it's got a nice healthy chunk of rows in it. So it's a table called T, and out of the box we can see that table has about 600 blocks, and it's got no empty blocks because we padded it out. Now I'm going to basically say, okay, let's take one of those columns, the object name, which is a fairly healthy size. Object name is going to be up to 128 characters, and I'll make it unused. Here's where we can see in the unused tab columns view that yes, we've actually taken one of these columns now from the table and taken it out of action. We've decommissioned it, so to speak, and it says we've got one. And in fact, if we go look in the user tab cols dictionary view, as opposed to user tab columns, user tab col shows you the hidden columns as well. And we can actually see there that the second column, which used to be object name, is now given some cryptic name. It's sys C002, the second column, a bit of a timestamp, but it's hidden, it's gone. And there is no way of getting that column back. You can't rename it back to object name, it's gone. So let's gather stats on that table. And you can see the table is still at 601 blocks. Now, obviously, that doesn't make, that's not unsurprising. We haven't done anything. All we've done is change the dictionary. Let's now run that command I said is a waste of time. Alter table, drop unused columns. I've gone through and scrubbed every single object name from that table. Now we can see that the count of unused columns is 0. That the column has gone from unused to actually totally wiped. If I go look in my user tab columns, it's now ceased to exist. There's no sys underscore column name anymore. The table literally has been effectively reshuffled to only have the columns that we want to retain. But let me go gather stats on this table now. And as we can see, what have we gained back in free space? Nothing. 601 blocks still in use, and empty blocks is 0. We actually have gained no blocks back. Now, I didn't put this in the demo, but let's assume object name was actually almost all of every single row, such that when we wiped it, we actually made a lot of these blocks available, that they crossed over into a free space boundary. Well, you'd still have a bit of a mess there, because now you've got either in your bitmap blocks or free lists, if you're of that vintage, you've now got this information that says every single block is now effectively on a free list or eligible for new rows. You're creating effectively an insertion potential maintenance problem now, because now we have a lot more free list or bitmap block maintenance to do, because every single block has gone from used to available for reuse. that in itself might cause you some problems. But even in this simple example here, where object name is not a big chunk of the row, we've actually gained no space back. The way I gain it back is to do alter table move. I move the table, regather some stats, and actually you see, now is the only time I actually get those 100 blocks back from 600 down to 500. But if I had to do alter table move anyway, I may as well just do set unused column and then do my alter table move after that. And in obviously more recent versions, I can do alter table move online, so I don't get an interruption to service. The actual act of doing drop unused columns pretty much is a waste of time. Now, I will concede, if you do set unused column and do alter table move, we will consume a tiny bit more space, because what happens is we have to actually store a little indicator in the row saying, oh yes, this was once a column. But it's going to be like a byte per row. It's not going to be something that's going to cause you any large kind of performance or space penalty. So for me, it's set a column to unused and then just do alter table move if you desperately need that space back. Now it says, let's go back to the slides and the question. At this point, you're thinking, well, thank you very much for that informative tutorial on unused columns, Connor, but it does nothing to actually answer the question, which is, I want to drop a column. I did set unused and I ran drop column, but it still stayed in unused tab cols. That's not what we saw in the demo. And as I said, I told you not to drop unused columns, and we're about to find out why and hopefully answer this question at the same time. So let's go back to our demo and continue on. Let's take a table T, a copy of DBA procedures, and move it but compress it. And compressing is a good thing to do, especially in data warehousing environments where you want to actually have data that is compressed to make it faster to read, better index density, etc. Compressed blocks are often good in an environment where you're not doing heavy DML. So I take a table called T. It was 600 blocks. I then removed a column. It made 500 blocks. And now I compress it, and it's dropped down to 141 blocks. So compression's a pretty cool thing. Now I'm going to pick a column and make that unused in my compress table. As I said, set unused, perfect, works fine. Table's compressed. I can grab a column and say, yep, let's make that column unused. In my view, that's all you really have to do. As we see, we had set count from the count for unused table columns is back to 1 again. We have 1 column that's unused. I can see it there in user tab cols. It's now the, what have I look at here? It's now the 6th column, and that's the one that's been flagged as unused. Let's now try to drop unused columns, and you'll get an error. You can't drop a column that's in a compressed table. This sort of makes sense because the compressed block is effectively about identifying duplicate values across multiple rows. Therefore, the only way, if you ran drop columns command to actually go fish out the rows and columns in question, would be to take that compressed block, uncompress it, have a look, remove the data, and then recompress it. Now, that seems a bit of a silly exercise to do, and that's why we block you from doing it. If you really want to, well, you can do that in the manual fashion. You can say, let's make that table uncompressed. That's a massive operation and makes the table huge. Let's now run drop unused columns. That's a massive operation that's going to walk through every single block in the table, and then you can compress it again. That's a massive operation that's going to walk through all the tables and burn lots of CPU. It's just not a smart thing to do. Comes back to my point. Just set the columns to unused and then you're done. Don't worry about running drop columns. The only time you have to do other work is if you want to actually move the table to gain the space back. Let's drop that table. Let's now explore maybe some boundary cases. Here's a table where it's now partitioned. I've got 2 partitions, P1 and P2. I've populated it up, but what I've got is to make one of the partitions compressed. So modify partition P1 compress and then move it to actually reload the data compressed. This is a bit more of an interesting scenario because half my data is uncompressed, half it is compressed. What are the rules in terms of setting columns to unused and dropping them? So I'll set another column to unused, object name, one column in user unused tab cols. And there it is, the second column now, saying, yep, that's now gone. Here's finally the answer to this person's question. If I'm on 12.1, I just connected here to 12.1. If you do alter table drop unused columns, no error. It simply says, yep, we're good. We've done the work. And it's very fast. And here's why. If you actually go look at your unused col tabs, it's still there. In 12.1, we made a decision. I honestly do not know if this was a bug or an actual decision, that if you tried to do drop unused columns on a table that contained compressed data, then it probably doesn't. You probably don't need to actually report an error. You've done all you need to do. We just simply let it proceed onwards. And that's what you get in 12.1, thus answering this question of how come I can do a drop column command and still have columns in the unused tab cols. We've reflected on that decision when you come to, I think, 12.2 onwards, and hence 19 as well. If you try to do it, even if just part of the table, like a partition or subpartition is compressed, then we will simply block the entire activity. So you'll see this now in all modern versions, but I wanted to put it out there because a lot of people are on 12.1. It's a long-term support release before you jump to 19. You may see this on your 12.1 version, depending on what patch level you're at, because for a while there, you could try to drop unused columns and we'd say, it's all good. Let's go back to the slides. As I said, I told you not to drop columns. You get these interesting anomalies. Let's look at another reason why I'd like you not to ever run the drop column command. Now, this one is a little bit more of an embarrassment for me and us at Oracle. Drop my table called T, create a table called T as a copy of DBA procedures. There's my table called T. It's got a certain amount of columns. I want you to focus on a few columns here. We've got obviously a number of columns up here, and then we have a column called pipeline. It's about in the middle. And I picked that just so it's easier to remember. It's pipeline, it's in the middle. I got some columns above and some columns below, but we're looking at the column called pipeline. I'm going to create a trigger on my table because often we create triggers on our tables. And I'm referencing the pipelined column, and I'm also referencing a column that comes before the pipelined column, the object ID. But it's just your stock standard trigger. And what I'm doing is, if the pipeline value is not null, so if there's anything in it, then I'm going to capture it into my, effectively, a debugging table. I'm going to capture every time this trigger fires and pipeline is not null. Keep that in mind. So let's test this out. I insert a row into my table, and as you can see, the third column there, pipeline, I'm actually inserting the value of yes for that, which obviously is non-null. So I select from my messages table, and you can see, nothing spectacularly surprising here. We actually logged a row in our messages table. If I do an insert where the pipeline value is null, I shouldn't see a row go into the messages table. And as you can see, there's still just the solitary row. For the value of 1, we got the row. For the value of 2, where the pipeline was null, we didn't get a row. So everything's working exactly as it's meant to. Let's do set unused columns. That's a good thing. Let's do drop unused column. That's a bad thing. Let me now jump straight in and insert a value for 3, object ID of 3 into my table. Pipeline is yes. So pipeline is not null. And look what's in my messages table. I didn't capture the row. The trigger didn't fire. And in fact, something odd is going on here. And this is just straight out a plain old bug. If I look at the trigger, even though I did a drop column, because that column didn't reference any column in the trigger still gets marked as in, let me try that sentence one more time. I dropped some columns, and even though those columns, or I suppose because those columns didn't reference any of the columns in the trigger code, the database kept that trigger as valid. But obviously, in terms of compilation, if I've done drop unused columns, I've actually shuffled the columns. Column 7 is now column 6, etc., etc. So the trigger probably should have been marked invalid because the internal compilation of what each column is has probably changed. Because we didn't, we have this problem. I actually do need to compile this trigger even though it's already valid. Once I compile it, I insert that value 3 again, and this time it's actually now captured. Moral of the story is, if you do drop unused columns and you have triggers on those tables, then in all versions of Oracle, your triggers may still be marked as valid and no longer be working properly. So if you want an even moral for the story, don't run the drop unused columns command. You don't get the space back normally. You have to do a reorganization afterwards if you do want to get the space back, so you may as well not do the drop columns, and you're likely to run into boundary conditions like this, where drop column unused returns no error in earlier versions of Oracle when the data is compressed, or you get this nasty bug here where triggers aren't firing properly. Avoid yourself all that hassle by just not running the drop columns command. Too long, didn't read, don't drop columns. Hopefully I can't be any more stressed any more than that. Okay, quick drink. As I said, big topics tonight, so even though I only had 5 on the list, it's going to be a struggle, but we'll do our best. DBMS job and 19C. Now, I did a blog post on that, and you can read that out on my blog, but there's a few other things I wanted to talk about and expand the demo that I did on my blog to talk about some of the things that are important when it comes to DBMS job in 19C. Now, quick caveat here, the demos we're going to run, I'm running this on a Windows box, and the scheduler can be a little bit slow to kick into gear, especially when the machine is running hard, recording this Zoom session and capturing video, etc. So hopefully the demos will work, but we'll do our best. I used the job parameter technique to pass parameters to DBMS job. This is no longer working in 19C, and can you explain why? So let's do a bit of background first and explain what the technique is, why it's a really cool technique, and then how you'll need to treat your code when you upgrade to 19C. So let's start with a demo, another big demo coming up here. Okay, so I'm going to connect to 12.2. So this is an older version of the database where we can use this technique, and then we'll talk about how it translates to 19C. I've got my table called emp. It's just a copy of the scott.emp standard table that we all know and love. And I might create a routine that belongs in my application to actually make an adjustment to an employee. I pass in an employee number, I pass in a salary, I do something breathtakingly complicated, namely update the employee for that particular salary. Let's give it a test. Here's my employee salary before I run the command. I make an adjustment to the salary and I just complete my unit test here. Yes, the salary was changed, so I'm happy that my program works. Let's roll back that change. So the employee goes back to its happy 1,300 salary. Let's now assume that that program, that application component which updates the salary is slow. It does a lot of work. Maybe it calls a web service to get some tax deductions or other bonus and all that kind of stuff. To simulate that, you can see that I've just added a line which says, I want you to sleep for 10 seconds. So now every time I call the employee adjustment program, which is calling 10 web services and an auditing program and all sorts of other stuff, it's slow. It takes 10 seconds. And our users don't want to see that on their web page. Real common technique is when something is slow, put it in the background. You know, in Unix, we simply put the ampersand at the end to bang it in the background. In the database, we throw it on the job queue. Scheduler or DBMS job. In Oracle 12.2, it was often we'd used DBMS job. So I'll roll that change back such that I don't have to rush you through this and try to capture things before they run. I've turned off the job scheduler such that we can actually see what things are on the job queue, and then we'll turn the scheduler back on. So this is a way I could make this whole process asynchronous. I'd submit a job which actually calls employee adjustment for 7934, set their salary to 1,000, and we can see the job number is actually job 181. And if we go look at the user jobs table, we can see there's a call to the employee adjust program to actually do our change. But from a user perspective, we've submitted the job, it's lightning fast, I'm done, I can move on to other things. it will obviously now have to be run in the background. And what we're hoping for is by the time the user goes back and looks at their screen, which might be a few seconds, 10 seconds, etc., the job has run and it looks like it all happened just instantaneously. So I'm going to do that. I'm going to turn on my job queue processor, and my poor little Windows machine is now going to hopefully catch up here and actually run this thing in the background. So we can see here that currently the employee salary is still 1,300, so my job hasn't run yet. So I put a few of these in there oh, there we go. Now the job has run. So at some stage in the background, the job has run. It's changed the salary from 1,300 to 1,000. I had another one there just in case. So that's all well and good. The problem is when you look at something like this, all of a sudden now I'm putting literal values into a call. I can actually see, employee 7934, they're getting a salary reduction to 1,000. I wonder what he did. Why did he get his performance review? What if this routine is, for example, resetting someone's password? Well, the password would be sitting there just floating around. Having that kind of stuff is a bad thing because the user jobs table is just sitting there. You can see all this kind of stuff. Oh, look, he's getting a salary reduction. That's what his new password's going to be. And in particular, if this is a really high volume kind of process, then you might have thousands of things being inserted, and every single one of them obviously is now a different piece of PL SQL because the literals are different. It now creates potential parse storms on your system because there's a lot of parsing going on. Let's roll that back and talk about how we've overcome it. One of the things that comes in that has always been in DBMS job is you get access to the job number before the job even runs, which almost sounds counterintuitive. So if I want to pass parameters to a job on the DBMS job queue, what I can do is I can create a table here called job parameters. And what I do is I can actually submit a job, get the job number back, use that job number to add more parameters, and then the job itself can actually, the actual PL SQL program itself can receive that job number as a parameter. It's like a chicken and egg thing. I don't know the job, but I want to send it, pass it into my program. And this is how we do it. This is my new employee adjustment facility. So the first thing I do now is the job number will be passed at runtime into my procedure. With that job number, I can actually go look up from my job parameters table what all the real parameters are, the employee number, their new salary, the new password, etc. And then I continue on as I normally would. So I'll turn off the job queue, and this is now how I do my job submission. Now, I know in my PL SQL code here, I actually have some literal values, but imagine this is actually a genuine application. This would be bound, etc., etc. The real beauty of this is my job here is I don't actually nominate any parameters inside that string. I'm hence also protected from SQL injection. I'm saying I want you to run my employee adjustment program, passing in the value of job, which as you can see is not referenced anywhere in this PL SQL block. Seems a bit strange. Once I know that job, this L job that comes back, I can use that to insert my job parameters. This is that great chicken and egg thing. I don't know what the job number is, but at runtime, I'll be able to access it. So if I look now at my job queue, all of a sudden, I'm not going to have any SQL injection issues. I'm not going to have any parsing issues, and I'm not revealing insensitive data because every job looks like this. Employee adjustment and pass in the runtime job number, which actually will be 183. You notice I didn't actually have the 183 literal there because that just has the same problem. It actually is this thing called job. If I look at my job parameters for 183, it will be employee 7934 and a new salary of 2,000. Let's now turn on the job queue scheduler and see what happens. So there's my running job. It's now running. So it'll run for 10 seconds. It's fake slow. Still running, still running. I got to make sure this actually finishes. So I'll wait a little bit longer. Please be finished. Good. This is why you can pass a thing called, let me scroll up a bit. Oh, I lost it. This is why you can pass it, here it is, a thing called job to your routine, even though you don't know what job is. when DBMS Job runs a program, it actually runs the following anonymous block. It says, go get, let me highlight this quickly, go get the job, which in this case was 183, bind it into this variable called job. And because your routine is simply called from within that anonymous block, you get access to that variable called job. So that's a really cool way of knowing what the job number is and using it to go get other information related to this job. It's a very cool technique. So this is what a lot of people have been doing for a long, long time when you needed to pass parameters to jobs. Really, really sweet. Avoids parsing, SQL injection, etc. Let's now move on to 19C. So connect to a different database. This is 19C. Create my job parameters table. Do my exact same program. I am going to be passing in the job, go get the details from the job parameters and do my work. So I'm simply replicating exactly what I had in 12.2. Turn off my job queue because I can see what's going on, and I'll do exactly what I did before. There's my anonymous block, just referencing this thing called job. I insert my job parameters for this job I've just created, and I can see it's there in user jobs, job number 401. I'm going to call emp_adjust. There's my job parameters. Everything's working exactly as it was for 12.2. Let's now turn on the job queue. So now it's actually going to do things, and we'll have a look. The first thing I think is, well, there's no DBA jobs running. Maybe it hasn't started yet. Because, as I said, my machine's got to slowly kick into life here. Okay, it still hasn't started. Let me give it a little bit longer and see if this thing is actually going to run. Still not running. Okay, so let's proceed on anyways. Here's an interesting thing. Not only is it not running, it's no longer on the job queue. So maybe I just missed it. Maybe it ran for its 10 seconds. It wasn't in one of those 3 queries like to see if it was running. Maybe I just missed it, but now it's gone from the job queue. But let's go look at our employee called Miller, whose salary was meant to change to 2,000 as part of that job. It didn't happen. That's weird. So the job appeared on the queue when I submitted it, but it never appeared as running. And at some stage, it simply disappeared off the queue and nothing happened. What's going on? Well, the job actually collapsed and failed. And so if we have a look here, a couple of job files were created. I'm just going to spit out them. Hopefully we can scroll and find the error. We got a no data found at line 5. So my job did actually run, but it crashed out and got wiped from the job queue. So let's go look at line 5 and see what actually went wrong. If I go look at my routine, I can see line 5 is this select statement, which is you've given me a job number, and that should be my key into the job parameters table. So you gave me job 400. There should be a row in job parameters with a value of 400, and I'll get my data and run just like it did in 12.2, but it didn't. So let's try debug what the problem is here. So I create a table called job debug. And all I'm doing, I'm not actually doing many salary adjustments now. All I'm going to do is when the job comes in, I'm going to actually log that in my job debug table because I was expecting that job number to be the job that goes with my parameters. So I'm going to submit a job and output the job number. So I've submitted this job as I had before, and I know that the job is job number 402. And I'm expecting 402 to be passed into my DBMS job employee adjustment program. If I go look at job debug, it wasn't 402. In fact, it was 103,970. Where on earth did that come from? Here's what happens in 19C. In 19C, the DBMS job infrastructure is now underpinned with the more modern DBMS scheduler routines. And this is actually an important thing for us because the DBMS job code is old and dates back to Oracle 7. And as we improve things like performance and more importantly, security, older code generally is more vulnerable to security issues. So we've kept the APIs for DBMS job, but now they redirect and become scheduler jobs, therefore using a much more robust code base. So when you submit a job now, in DBMS job, we actually under the covers create a scheduler job. And we can actually see what we did here. We created a job, an actual physical database object, a scheduler job, called DBMS job $402. But the job number that gets passed around is actually the object ID. That's what we pass into. Now, you could argue that's a bug. It's just a decision that's been made by the development team that that's an appropriate number to pass in for the value of job. As we said, 19C, it's all about the scheduler, not about DBMS job. It's simply an API now. So how do we fix it? Now that we know that it's the object ID, and we saw that the object name contains the old job number, you'll need to augment your code like this. The job number that gets passed in is an object ID. I use that object ID to look up user objects, use the object name to strip off that leading prefix, and that leaves me with the original job number 402. Now I can use that to go look up my parameters and continue on. So if you're using this technique, let's try that sentence again. If you were using this technique in all previous versions, once you get to 19, this is the slight addenda you need to make to your code. Now you then submit it. Actually, I think I did a test here to see if I can get this to work. So now I submit it like that. I've got my new program now that goes and gets the job number from the job name. It's 1300, and there's my job run 2000. And suddenly the technique works once again, and you don't have any issues with parsing. Okie dokie. That's part 2 of DBMS job in 19C. Let's look at some other implications now. So now I'm going back to 12.2. I'm creating a table called T with a single value of 0 in a column, and a table called T1 just to actually store how many times we actually run a job. So my table called T has the value of 0 in a row. Here's a bit of a cryptic piece of PL SQL, but let me explain how it's going to work. We're going to run this from a job. Every time we run it, we're going to record when we actually ran it. And then we're going to run this query, which is select, etc., and this is the key one. I'll go get the value from the column in T, which currently is 0, and then I'll do 1 divided by that value. Now, 1 divided by 0 will raise an error. So the first time I run this routine, it's going to crash. But before I crashed, I updated the value to be from 0 to 1. So the second time I run it, it'll be 1 divided by, what's that, 2? Same thing, it'll crash again. The third time I run it, by this stage, the value in T will have gone up to the value of 2. This will be 1 divided by 1, and it won't crash. So I'm trying to simulate here the kind of thing that occasionally happens in jobs, which is they crash for some reason. Some data wasn't present, some other architecture wasn't available. For some reason, the job has crashed, but the DBMS job infrastructure, as you know, will retry those jobs. It failed, mark the failure count as 1, and give it another run, and continue to do so. If it fails 16 times, it doesn't get tried anymore. But that's what DBMS job does. Let's see that in action. Turn off my job queue, submit the job, it's job 201, just so we don't have to wait for the job queue. I'll just manually run it. I manually run it, the job failed. That's what I expected because it's 1 divided by 0. And we can see in user jobs, it says, yep, there's your job. It has a failure count of 1. In normal operation, DBMS job would wait 1 minute and then it would try again. We'll circumvent that by manually running it. We'll run it again. It failed again. The failure count is now 2. Normally DBMS job would now wait another minute. In fact, it does a binary back off, but let's assume it's looped around again and it tries again, and this time it runs. Because each time we've updated that value in T, and eventually the 0 divide error no longer occurs. So this is what DBMS job does for us by default. It will try to run something up to 16 times. If it fails, and hopefully in one of those 16 times, it will actually sort itself out. And eventually when it's done, right, the job disappears. So the job was submitted just for a one-time execution. It finally succeeded, it's gone. Let's now repeat that exact thing on 19C. So here I am on 19C, My table called T with initial value of 0, that's going to go up by 1 each time. My table called T1, which is the number of runs. And here's that exact same program. We're doing the exact same thing on 19C. Each time we'll update T by increment of 1. So it'll 0 divide on the first few executions and then finally should work. I'll turn off the job queue and submit a job. It's job 421, and I'll run it. No error. That's a bit weird because it was meant to get an error on the first execution. No error. Let's look at the job. 0 failures. That's a bit strange. Let's give it another run, see what happens. Still 0 failures. Run it again. Still 0 failures. And in fact, if I run it as many times as I want, the failures count never goes up. If I go look at my table called T, which was meant to go from 0 to 1 to 2 to 3 to stop the 0 divide, it hasn't gone up. And if we look at T1, which is a log of every single time we ran the job, we captured nothing. dbmsjob.run, manual invocation of a job in 19C is a no-op. Doesn't do anything because it's now been bypassed into the scheduler routines. So it doesn't actually do anything. So be aware of that. When you go to 19C, dbmsjob.run, when the job queue is turned off, does nothing. Let's now turn the job queue on. Now that job is still in there. It should now actually start doing its kind of stuff. So there's my job. It's in there. It has no failures, but now the job queue is on. It should eventually come along and actually see this job and actually run it. The job's disappeared. So the job has been run. Now hold on a second, you're thinking, in dbms job in previous versions, this would have failed the first time. Failures would be 1, then failures would be 2, then failures would be 3, and then eventually it would finally succeed and disappear. But this one looks like it's disappeared straight away. It's gone. If we go look at our T table, it went from 0 to 1, single execution, and look at our T1 table, we can see it was run only once. So it's a change in behavior when you get to 19C. Whereas before, when a job would fail, it would be retried 16 times. Because we're now using the scheduler, in 19C, dbms job, if it fails, it's a one-time invocation, it's done. Important thing to realize if you are relying on dbms job to do things like automatic retry. So be aware of that. Things are different in 19C. The behavior has changed subtly when you go from dbms job to dbms job, which is actually using the scheduler. So these are things that you should be very, very aware of when you come to upgrade. Whew. Okay, we've covered 2 topics. We've got 12 minutes left. Let's see if we can get 3 topics done. Table maintenance. I've archived off some old data from one of my tables. Should I reorg the data? At what point do I think, yep, I should actually do something in terms of reparative maintenance to this table or a reorg? How do I know? And my general rule of thumb, and when I say rule of thumb, this is my first position, and that is it's probably not worth it. And that's what I generally do. I think unless I can prove to myself there is a benefit to be gained, then why bother? I may as well just do nothing and keep an eye on things. If performance degrades or there are other opportunities, then fine. But I don't go, oh, because I've done data maintenance, I must do a reorg, which a lot of people tend to do. I've done data maintenance. I need to prove to myself I should do a reorg before I actually go ahead and do it? And the question is, how do we do that? Let's do a demo. So I'm going to create a nice big table here. This is 20 copies of DBA objects, about 1.5 million rows, I think. If we go look at the data, was it? Yeah, 1.5 million rows. It's got 32,000 blocks, give or take. That's the size of the table. Without actually knowing the genuine number of blocks, I could probably make an estimate on the number of blocks using the other information. If I know how many rows are in the table, 1.6 million, I know the average length of a row, I can actually say, well, that times that is the number of bytes, divided by 8192 is the number of blocks. Now, every block has percent free in it, so I can do that effectively times it by 90% to add that padding. And that gives me an estimate as to what I think the blocks probably would have been. It came out at about 29,800. So you can see my estimate's a bit low. My estimate came out, the real value is 32,200. My estimate was 29,000. But now that I know those two figures, I can make an adjustment. I can say if I do 32,000 divided by 29,000, it gets me about 1.08. So it's a reasonable assumption to say there's about 8% overhead in every block. If I factor that in to my estimate, I can now get a reasonably accurate estimate of how many blocks a table should consume given a number of rows and the average size of that row. So I'm pretty close there. If I, 32,000 and change. Sorry, Q&A. Someone wants the video? Yes, this will definitely be made available. Keep an eye on my Twitter account. I'll publish when the video is available. Thanks for that question. Let's now do some data maintenance. Did I press pause too fast? Dear, oh dear. I deleted a third of all the rows. So I did a delete where mod row num, 3. So effectively a third of all the rows are gone. I deleted 500,000 rows. Let's regather stats. Now I can look at my calculation of estimated blocks versus the number of blocks in the table. Now I've done no reorg of the table, so the number of blocks is unchanged. It's 32,250 something. But my estimate now is I think the table should consume about 21,500 blocks. So using simple database stats, the number of rows, the average row length, and a little bit of padding, you can get an estimate of how big a table probably should be, and then compare it to how big it actually is on disk at the moment. That's a nice little thing. It's like, well, okay, if I did do a reorg, I'm probably going to get about 11,000 blocks back. And so that's your first thing, is quantitatively find out what is the potential savings you're going to get. Now, if we do an alter table move, let's see how close my estimate was. Alter table move to regain that space, regather some stats, and I came out at 21,538 as compared to 21,444. So my estimate was pretty good, and I actually got 11,000 blocks back. That's great. Getting space back isn't necessarily, though, the proof you need, because who cares? 11,000 blocks. Maybe that's worth it because maybe it's going to make your backups smaller. Maybe, it's generally just getting space back. I don't think often fully justifies doing a reorg. And here's the other thing: is it actually worth it? So if your table is going to have more activity, let's see what happens. Create my table again from scratch, 20 copies of DBA objects. As we saw, it's 32,000 blocks. Here's the delete we didn't see before. I delete half a million rows, basically a third of all the rows. But if my table is expecting more activity, if I delete 500,000 of the oldest rows, but over the next 3 weeks, I'm going to be inserting, not obviously in one hit as an example here, but over the next few weeks, I'm expecting another 500 million rows to come in. Well, the table is 32,000 blocks. As we saw there, if I regather stats, the table is still 32,000 blocks. So deleting a third of the table, inserting brand new rows, that space got reused. It would have been a waste of time to reorg that table down to 21,000 blocks because it's just going to go up to 32,000 anyway. And we see here that even though we didn't do a reorg, the table didn't grow without bound. It actually reused that free space. So justify that you're going to get some space, but then justify if it's actually worth it, because if you're going to have new activity, new insertions, you're probably wasting your time doing a reorg. That space is just going to grow anyway. The second thing is it worth it based on the type of access you do? I'm going to drop my table. Here it is again, 20 copies of DBA objects, but this time I'm going to put an index on one of the columns as well. Let's wipe out my 1/3 of the table. There's my data maintenance. It's working a bit harder now. Commit that away. let's look at some kind of queries that you might run on this table. The first one here is just a max created. That's not an index column. That's a full table scan. That cost me about 33,000 consistent gets. There's this one, which is a large index range scan. So even though I'm using an index, I'm actually querying 700,000 rows here. So you can see that's 26,000 consistent gets. And here is a much smaller range scan because the system value of system is much smaller number of rows, only 6,000 rows, and it's only 487 consistent gets. So I've got a full table scan, about 34,000, large range scan, 26,000, small range scan, 500. That's after I did my big data maintenance operation. Let's now reorg the table. Let's see if it actually was worthwhile doing a reorg of the table. And an alter table move, rebuild the index. So remember those 34,000, 26,500. The full table scan does benefit. It goes from 34,000 down to 21,000. So if your application does a lot of full table scans, then maybe a reorg after data maintenance is a good thing. It's going to be worth your while. Once again, caveat there is if the table is going to grow again, maybe you have to balance that off. Large range scan went from 25,000 down to 17,000. Once again, if you're doing large index range scans, there's probably some benefit to actually doing a reorg. Small index range scans, primary key lookups, etc. 450 down to 425, really no difference. So here's the key thing is a reorg is fine as long as you can justify the space savings, but also justify the ongoing benefit to your application in the way your application uses the data. If it's all full table scans, reorgs are probably going to be a good thing. If you're always going to be replacing the data you just deleted, reorg's probably just a waste of time. But at least now you can have some quantitative analysis to actually prove, are my reorgs actually getting me a business benefit? And if you can't answer that question with a yes, then don't bother doing them. It's just burning resources that you don't need to burn. So here's I have a couple of rules of thumb when it comes to doing reorgs. If it's what I call your final resting place, and often, like for example, I'll have maybe 10 years worth of data. I'm maybe grabbing the last 8 years and putting it somewhere, and that's going to be query only. If something is its final resting place, it's not going to be touched again. I'm going to reorg the daylights out of it once. I'm going to compress it. I'm going to reshuffle the data so it's really good clustering, come up with the best indexing strategy, maybe put some of it in memory, and I'm done. And I'll never touch it again. So data that's about to go into its final resting place, perfect for actually doing a heavy duty reorg stuff. The other one, which is interesting, is sometimes what I call the initial resting place. What I mean by that is if I'm loading data into a data warehouse, sometimes I'll load that data into its own table in isolation. Therefore, once again, I can compress it, index it, whatever, and then either ship it into my warehouse or exchange partition into my warehouse, etc. Knowing that I'm not going to be doing anything with it, it's once again just going to be read only. So final resting place, initial resting place, generally things between those two things where the table will still be actively in use. I'm going to have to make sure I can prove it to myself that I'm going to get some benefit. And I should say that it's not just space reclaim that is the thing that you might justify doing reorgs. Now that we can do so many things online in Oracle 12, one of the things that we can do is, for example, is do attribute clustering and compression, such that sometimes, even though we have a table which is growing over time, we'll take that time occasionally to reshuffle the data to make our indexes really, really fantastic. And knowing that they will then degrade again, but we might get a lot of application benefit just for that point in time. I hate to say it, but we are done. I didn't get through, obviously, all the stuff we wanted to get through. That will be saved for the next office hours, but hopefully you found those interesting. We went, I like filling these things with demos so you can see real life use of the technology. Hopefully you enjoyed this session. For the person that asked the question, yes, it will be made available on YouTube in the very near future. As I said at the start, please reach out to me on Twitter if you have any questions or just comments or just want to hang out. As I said, if you go to follow me on Twitter, you'll see recently I posted hopefully a funny video that you would like to see about the kind of things that database people say, not just on office hours. As always, thanks for your time. Please stay safe. We'd love to see you all back here every month for office hours. Until then, bye for now, everyone. Have a great night.